Assalamu alaikum and welcome to grade 12 maths class with me Mariam Shafa Ibrahim from CHSC. Today we are going to do the last part of this topic, algebraic methods, which is converting an improper fraction into partial fraction form. Now what is an improper fraction? An improper fraction is a fraction which has a numerator that is greater than the denominator, right? Now for number fractions, you can very easily see whether they are improper or not. But when we are dealing with algebraic fractions, sometimes it's not that simple, right? So when we decide if an algebraic fraction is improper or not, we look for the highest power of the unknown in the numerator and the denominator. Now, if the highest power of the unknown in the numerator is greater than or equal to the highest power of the unknown in the denominator, then we can say that the fraction is improper. Now, look at the example here. X squared plus 5x plus 8 divided by x minus 2. Now, if you look at the highest power of x in the numerator, that's 2, and the highest power of x in the denominator is 1. So, that makes this a improper fraction. Okay. Now, look at this example. X cube plus 5x minus 9 divided by x cube minus 4x squared plus 7x minus 3. Now, if you look at the highest power of x in the numerator, that's 3, and the highest power in the denominator is also 3. So, since they are equal, this is also a improper fraction. Alright. So, the rule here is if the numerator has a highest power of the unknown which is greater than or equal to the highest power of the unknown in the denominator, then we can say that the algebraic fraction is improper. Now here I have some algebraic fractions. What I want you to do is look at these fractions and see if you can identify the improper algebraic fractions. Alright. Go through the fractions, look at the numerator and the denominator, the power of the unknowns, and see if you can identify the improper algebraic fractions. Keep your answer in mind. I'll be showing the answer shortly. Alright, you can see if you guessed it correctly. Okay, I hope you have made your guesses. Let's check your answers. So here, these 4 fractions are improper algebraic fractions. Let's go through them one by one. Now, if you look at this fraction, it's very clear, right? The highest power on x is 5 in the numerator and the highest power of x in the denominator is 4. So, that makes this a improper fraction. Doesn't matter whether we are adding or subtracting. We just need to look at the power of the unknown. Alright. Same way in this one, it's also very clear, right? The highest power of x in the numerator is 4 and the highest power of x in the denominator is 2. So that makes this a improper fraction, right? Now if you look at this fraction, the denominator has double brackets. So before we can decide if the numerator has a higher power or not, we have to remove that bracket, right? So you don't have to remove the whole bracket. You just need to figure out which one will give you the highest power of x, right? So if you multiply that 3x by the x in the second bracket, that will get you 3x squared. That would be the highest power you can get in x by removing the double brackets, right? So the denominator has power 2 as the highest power, and in the numerator we have highest power 3. So that makes this a improper fraction. Alright. Now in this last fraction also we have something that can be simplified in the denominator, right? So you need to simplify that before you can decide whether it's improper or not. So if you multiply this x by the x in the first bracket, you would get x squared, and x squared into the x in the second bracket will get you x to the power 3. So x to the power 3 is the highest power of x you can get by simplifying out this denominator, right? So the highest power of x in the numerator is also 3 and the denominator is also 3. That makes this a improper fraction. Alright. So I hope that's clear. I hope you guessed the answers correctly. Okay, let's move on. Now, before an improper algebraic fraction can be expressed as a partial fraction, you need to convert it into a mixed fraction. There are two ways you can do that. converting an improper algebraic fraction into a mixed fraction. First is using algebraic long division, which is something you are very familiar with, right? And the second method is using the relationship fx is equal to qx into divisor plus remainder. Alright. So today in this class we are going to practice using both these methods to convert improper fraction into mixed fractions and finding unknowns. Now look at the example here. Given that x cubed plus x squared minus 7 divided by x minus 3 is equivalent to ax squared plus bx plus c plus d over x minus 3, and they are asking us to find a, b, c and d. Now before we go into solving this problem, let's analyze this fraction a little bit. Alright. Let's say you have a number fraction like that, 7 over 2, that can be written as a mixed fraction 3.5, right? Where 3 is the quotient, 1 is the remainder and 2 is the divisor. Now, if you look at that mixed fraction there, ax squared plus bx plus c, that's your quotient, d is your remainder and x minus 3 is the divisor. Alright, so that's in the form of a mixed fraction. Okay, let's try to solve this question. Now, since they have given it in the mixed fraction form, we are going to try it with the first method, alright, using algebraic long division. So, we are going to divide x cubed plus x squared minus 7 by x minus 3, the improper fraction, and try to convert it into a mixed fraction, okay. Now, before we can start dividing, just to remind you, we need to make sure that we have all the powers starting from the highest power descending up to the constant, right? So if any terms are missing, you need to include that. So here we have x cube, we have x squared, but we don't have an x, right? X to the power 1 is not there in the numerator, right? So we need to include that with a coefficient of 0, alright? And then we have the constant minus 7. Okay, let's start dividing. Now we want to get a x cube first. So we need to multiply x minus 3 by x squared. And when you multiply, you get x cube minus 3x squared. Now subtract that to get the remainder and bring down the next term. Now to get that 4x squared, we need to multiply x minus 3 by 4x, right? And when you multiply, you get 4x squared minus 12x. Subtract that out to get the remainder and bring down the last term. To get the 12x, we need to multiply x minus 3 by 12, which gets us 12x minus 36. So, subtract that out to get the final remainder, right? So, here, that's your divisor, there's your quotient, and there's your remainder. So, we can say x cubed plus x squared minus 7 divided by x minus 3 is equal to x squared plus 4x plus 12 with a remainder of 29, right? So this can be written as a mixed fraction, x squared plus 4x plus 12 plus 29 over x minus 3. Now once you get that as a mixed fraction, we can equate it to this part of the equation to find the unknowns a, b, c and d, right? So all you need to do is equate the coefficients to get the answer. So here we have a is equal to 1, b is equal to 4, c is equal to 12 and d is equal to 29. Alright. So here we have used long division to convert the improper fraction into a mixed fraction to find the unknowns a, b, c and d. I hope that's clear. Now we are going to do the same example using the second method. Alright. So here it says given that x cube plus x squared minus 7 is equivalent to ax squared plus bx plus c multiplied by x minus 3 plus d. And we are again trying to find a, b, c and d. Now this time that's given in the form, this part of the equation is given in the form fx is equal to qx into divisor plus remainder, right? Where x minus 3 is the remainder. Okay. So we are going to substitute values of x to find the unknowns a, b, c and d. So first I'm going to substitute x equal 3, because when I substitute x equal 3, we can get a 0 there, right? 3 minus 3 gets you that 0, and when you multiply that with this bracket, the three unknowns a, b and c will get cancelled out, and we can easily find the unknown d, right? You should always check values where you can eliminate some of the unknowns when you have more than one unknown, right? So now we got d, we can use the value of d to find the value of c. Now here I am substituting x equals 0. You can substitute any values, but make sure you can eliminate some of the unknowns. Now I have chosen 0 because when I substitute 0, any term multiplied by x would get cancelled out, right? So by substituting 0, I can cancel out a and b, and since I have already found d, which is 29, I can find the unknown c by solving it out, right? So I can get a linear equation with only c as the unknown. So by solving that, I can find c. So here c is equal to 12. Now we have two unknowns, c is equal to 12 and d is equal to 29. Okay? We can use that to find the remaining two unknowns a and b. So now I am going to use those two values c and d, and by removing the brackets and equating the coefficients, we are going to find a and b. Alright? So removing the double bracket ax squared plus bx plus 12 into x minus 3 and then simplifying it out, I can get terms for the coefficient of x cube, x squared and x, right? Now, if you know how to get these coefficients straight away from here, you don't have to do all that work, right? We can just get these coefficients. Now ax squared into x will get you the only x cube, right? There's no other term that will get you an x cube. So we can get the coefficient of x cube like that, right? Similarly, if you want the coefficient of x squared, bx into x will get you that bx squared, and ax squared into the constant will get you that minus 3a, right? So when you simplify that out, you can see that the coefficient of x squared is b minus 3a. So instead of doing all this work, you can straight away get it from there. Similarly, if you want the coefficient of x, the only way to get x would be 12 into that x, that gets you the 12x, and bx into the constant minus 3 will get you minus 3bx, and then you can simplify that to get the coefficient of x, which is 12 minus 3b. Alright, so if you can figure that out, you don't have to do all this working, you can straight away get it from there. Now we can equate the coefficients to x cube plus x squared minus 7 and find the unknowns, right? So if you equate x cube, the coefficient of x cube, we can get a is equal to 1, and then I am equating the coefficient of x squared to get the value of b. Now already I have found a, so I can use that a there, right? And then using the a, I can find the value of b, which is equal to 4. Now if you want, you can even equate the coefficient of x. Now since there is no x here, the coefficient of x would be 0, right? So you can equate minus 12 minus 3b equal to 0, and then solve that out. 3b is equal to 12 and b is equal to 12 divided by 3, which is equal to 4. So same way we can find the value of b, right? So either coefficients you can use to find the value of b, which would still get you the same answer. So here we have found a is equal to 1, b is equal to 4, c is equal to 12 and d is equal to 29. Alright. So we have solved the same question using the second method here. So I hope both methods are now very clear for you, right? Now let's do a different example here. Fx is equal to x to the power 4 plus x cube plus x minus 10 divided by x squared plus 2x minus 3. Now that's an improper fraction, right? We have x to the power 4 in the numerator, x squared in the denominator. Now that improper fraction, they are saying that it can be written as ax squared plus bx plus c plus dx plus e over x squared plus 2x minus 3, and we have to find the unknowns a, b, c, d and e. Alright, now since they have given it in the form of a mixed fraction, I am going to do this using long division, but you can do it using the second method as well. Alright, so let's try long division on that. So before we start dividing, remember all the terms has to be there from the maximum power to the constant. So here we have x to the power 4, we have x to the power 3, but we don't have x squared. So you have to write the missing term with a coefficient of 0. Alright, and then the remaining two terms x and minus 10. Okay, now let's get that x to the power 4 by multiplying x squared plus 2x minus 3 by x squared, right? So that gets us x to the power 4 plus 2x cubed minus 3x squared. Subtract that out to get the remainder and bring down the next term. Now to get that minus x cubed, we have to multiply x squared plus 2x minus 3 by minus x, right? Which gets us minus x cubed minus 2x squared plus 3x. Subtract that out and bring down the next term. Now to get the 5x squared, we need to multiply x squared plus 2x minus 3 by 5. And then, which gets us 5x squared plus 10x minus 15. Subtract that out to get the final remainder, minus 12x plus 5. So we can say that x to the power 4 plus x cubed plus x minus 10 divided by x squared plus 2x minus 3 is equal to x squared minus x plus 5 with the remainder of minus 12x plus 5, right? So now we can write it as a mixed fraction. X squared minus x plus 5 plus minus 12x plus 5 over x squared plus 2x minus 3. Alright? And then we can equate it to this mixed fraction to find the unknowns a, b, c, d and e. So just equating the coefficients. We have a equal 1, b equal minus 1, c equal 5, d equal minus 12 and e equal 5. Alright, so we have used long division to convert the improper fraction into a mixed fraction and found the unknowns. If you want, you can do the same question using the second method as well. You would still end up getting the same answers. Alright, so I hope you have understood how to use both these methods. Now, if you have understood this lesson, you should be able to answer the questions in exercise 1C in your P3 books. There are 10 questions in this exercise. If you have the book, you can refer to your book. And if you don't, I'm sure your teachers will share the exercise in your Google Classrooms. And I have also included the exercise and the answers in this presentation, which will be available for you in the MOE website. So you can download it from there and practice these questions as well. Alright, and if you have any doubts, please approach your teachers and clarify your doubts. I hope you understood this lesson well. Thank you very much for joining me in this class. Assalamu alaikum.